Thank you very much for the opportunity. I'd like to just review with you the development of our donor-derived cell-free DNA test, which we now term Prospera, and the elements of our technical assessment and dossier that we've presented for the draft coverage decision. Currently, graft failure rates are high and costly. This data is well known. This gives you an idea of the number of kidney transplants that are performed in the United States. The failure rate, which is, on the one hand, one of the great success stories of transplantation biology. In any event, it is a great success story in transplantation, the reduction of graft rejection over the first year or two. But it is also clear that later graft rejection remains a very significant problem and an important utility that needs to be addressed by new tools and new management of organ recipients. And it is also clearly true that the traditional tools that we use to manage acute or active rejection in kidney transplant, being serum creatinine and biopsy, have inadequacies and are not accurate enough in certain kinds of presentations. Now, in terms of the evolution of kidney allograft health assessment, the clinical utility of monitoring graft rejection is well established. That is, with the use of standard of care, we have in fact seen a dramatic improvement in the management of particularly early graft survival. We have the use of donor cell cfDNA is validated for transplant rejection, and there are numerous publications that indicate its role in transplantation. CMS has recognized this by the approval of its own version of cell-free DNA about a year ago, and that's in L37303. And the Prospera draft LCD, which I'm discussing the technical basis of at this time, has been preliminarily accepted by CMS, and the performance in its analytical and clinical validation has been reviewed. So let me just quickly make some points about both the published analytical validation and the published clinical validation. Prospera measures donor-derived cell-free DNA assay without previous genotypic information. The basis of the test are more than 13,000 PCR amplified SNPs, and this assay has been extensively validated using a CLSI standard protocol in over 1,000 replicate samples. These included actual related and unrelated DNA mixture samples. The limit of detection, limit of quantification, repeatability, and inter-run precision are non-inferior to the current accepted CMS standard in this area, and in many ways exceed the previous performance of in publication. Our clinical validity study was done with a leading transplant center, the University of California at San Francisco, and used biopsy matched samples. We had a very large sample of biopsy matched patients that we included. The included sample was ethnically diverse, reflective of many of the elements of our complex ethnic society. We included both for-cause and protocol biopsy patients in our study, which was, by the way, prospectively determined. That is, the cutoff was for the positivity and non-positivity of the assay was prospectively determined, and both the pathologists and our determination of cell-free DNA was blinded to the biopsy results and other elements of the biobank. And included in our samples for clinical validation was a broad range of pathology, including T-cell, B-cell, and mixed pathologies that were all, and these samples were all analyzed on BAMF criteria from 2017. In terms of summarizing the clinical validity performance, as you can see, the test performed with greater sensitivity and PPV than serum creatinine in this cohort. In addition, the performance of Prospera in clinical active rejection as opposed to subclinical active rejection, the sensitivities were similar and the PPVs were also similar. So, in summary, Natera has a 15-year or more experience with cell-free DNA testing. This gives us enormous experience in controlling this assay and in the analytic and real-world variables that affect cell-free DNA testing. And this was brought to bear both in the development and now in the clinical use of this assay. Our robust and sensitive core technology can meet medical needs and has shown to meet medical needs in prenatal care, in oncology, and now in transplant medicine. Renal transplantation is a large area of transplantation and it has important unmet needs. We think that we have demonstrated that Prospera is more accurate than serum creatinine in assessing, as part of the assessment for active rejection, and will demonstrate, and we have preliminary data that will demonstrate improved biopsy utilization. Thank you very much.
So thanks for that presentation. I'm Steve Potter. I'm a transplant surgeon in Texas. I'm also a consultant for CareDx, and I had a couple of questions. First about study design. So this was a retrospective single-center study on bank blood. In your talk, Dr. Billings, you mentioned this was blinded clinically, but my understanding from your publication is that the only part of the study that was blinded was the pathologist reading.
No, we were blinded as well. In other words, as we measured cell-free DNA, not knowing the status of that.
So my question really revolves around the selection bias inherent in that kind of study design and the potential lack of generalizability of these findings to the general transplant population around the country.
Well,
for example, you mentioned that it's an ethnically diverse society, but it looks like only 25 patients, 14% of your population were African American. So it's hard to know how you could generalize to the entire country based on that small sample size from one center when about 55%, 50% of the transplant recipients in the nation are African American.
Right. So I would not say that more data isn't better, and it's certainly true that, and we're going to do a registry study and other studies to get more ethnic diversity. I will say that this UCSF center where the biobank was developed is a national center, draws samples from and draws clients from all over the country. In addition, when you compare our clinical validity study to the published study that was used for the incumbent, ours is at least as good as that one, and in fact is more ethnically diverse than the previous publication.
Yeah, so my understanding is that publication that I think that you're referring to, that was a 14-center prospective multi-institutional study.
Right, but as I said, if you look at the ethnic diversity in the reported sample, ours is more ethnically diverse than that sample was.
Debatable, I guess. And So my follow-up question is really about your histopathology. So in your paper, you say that your criteria that you're going to use is BAMF 2017 criteria, which of course we all in the community understand and appreciate. But then it looks like in your methods section, you deviate significantly from the BAMF criteria.
No, I don't think we deviated significantly from the BAMF criteria at all. We've analyzed the data both on BAMF 13 criteria and on BAMF 17 criteria. Our classification of samples is accurate given the BAMF 17 criteria. And the issue really is in a couple of cases where there's both T-cell and B-cell evidence of antibody-mediated rejection, how one classifies whether that is a T-cell mixed or a B-cell predominant rejection. It was a couple of samples that when we've looked at it in retrospect, were properly classified.
Because it looks like line for line, your ABMR definition is totally different than the BAMF criteria.
No, it's not.
The BAMF 2017. And then you use a, quote, borderline ABMR import definition, which I don't remember seeing at all in BAMF 2017. I don't think that's the criteria of BAMF 2017.
We separated out for analysis borderline cases and defined them in the paper. When we were commenting about BAMF criteria, we used traditional or the accepted BAMF classifications.
Thank you for clarifying that.
Yeah, happy to.